Hello, and welcome to the first parts of a series about building a test runner. Today, I'll be laying out the motivations, the target features, and a few potential target architectures. There'll be no code in this one, just a quick overview to get us started. So, why a test runner? I expect most folks who watch my videos make a living through building web apps. Different web apps draw from the same well-known set of building blocks in order to power their feature sets. A test runner also draws from a similar, I'll bet, more abstract set of building blocks. For example, instead of rendering HTML to the browser, rendering escape sequences to a terminal. Instead of client-server messages over HTTP, inter-process communication over pipes. Instead of caching data in an in-memory store like Redis, caching data in the memory of a regular running process. Above a certain level of abstraction, it's all the same. And that's where we get to innovate and develop transferable knowledge. Knowledge that can be applied to web apps, desktop apps, CLI tools, sensor networks, whatever. And because they're all the same, they can leverage the same interfaces. So we're going to get a lot of reuse out of these building blocks. So what does a test runner look like? Fundamentally, it's a tool, usually run from the command line, that takes in a set of test files and returns a set of results, indicating whether each test passes or fails. One valid implementation is to iterate over each file, iterate over each test in the file, run the test, and report its outcome, and so on and so forth. In this way, one test is run at a time. Most test frameworks prior to ES 2015 and the subsequent proliferation of language features were implemented in this way. But today, it's far easier to do better by starting multiple threads or processes and distributing test files amongst them, and then running those test files in parallel. Within each test file, it's also becoming more common to allow multiple test cases to run interleaved, to take advantage of idle time when a test case stops to wait on I/O. In this way, tests can run in parallel and fully utilize CPU throughput. From here, we can make further optimizations. It takes time to spawn threads or processes and then load test runner code into each one. Instead of doing all of that on each and every test run, we could instead keep them around to reuse on subsequent test runs. We can cache the workers to speed up the start time, trading memory for CPU usage. This cache can be managed by a worker pool that can take commands from a CLI. This design should start to look pretty similar to a typical web app interaction between a browser UI and an API server. And in fact, there's nothing about this design that precludes issuing commands from a browser. So instead of running tests from a CLI, you could decide to run tests from a browser window instead, or from a desktop app, or from a code editor. And why stop there? This pattern can be applied to more use cases. We can have a cached process for compiling TypeScript, It can cache each file that it compiles and take change notifications from the file system. Historically, compiling JavaScript has always been very slow, and some degree of caching has always been necessary, whether it's in Webpack or in ESBuild. We can also have a cached process to provide browser tabs to any test that requires them. Now, it is the case that Chromium starts up very, very quickly. However, we wouldn't want each test that needs a browser to spawn a browser process independently, as this would oversaturate CPU throughputs. We also wouldn't want to force users to use a different test runner in order to run code in a browser. So, that is the high-level plan. In this series, I'll walk through the implementation of each of these designs. I'll also touch on developer affordance features, like different ways of expressing reusable test setup or different ways of expressing test cases. I also plan to touch on extensibility and observability. For example, can the features of Playwright be implemented on top of this test runner? Or does anyone with an exotic feature set always need to roll their own? And after all is said and done, hopefully we would have revealed some useful software design insights that we can leverage on other projects. So with that, that's it for now. Stay tuned for more, and I'll be back soon.